Good evening. So today, as I told you last time, I will give you another two more exercise problem for sensitivity analysis. And I believe these are the last example problems for sensitivity analysis. Okay? So the first example is about steak sauce production company problem. And Jack Daniels Incorporation produces two steak sauces, spicy Diablo. Is it Diablo? Diablo, okay. And mild Red Baron. And these sauces are both made by blending two ingredients, A and B. Okay? And a certain level of flexibility is permitted in the formulas for these products. And the restrictions are the Red Baron must contain no more than 75% of A, and Diablo must contain no less than 25% of A, and no less than, I think it should be, okay, no less than 50% of B, and up to 40 quarts of A and 30 quarts of B could be purchased. And Jack Daniels can sell as much of these sauces as it produces at a price per quart of $3.35 for Diablo and $2.85 for Red Baron. And A and B cost $1.60 and $2.05 per quart, respectively. And Jack Daniels wished to maximize its net value from the sales of these sauces. Okay, that's the problem we've got. So we define 6 decision variables. D is the quarts of Diablo to be produced. R stands for the quarts of Red Barons. And AD is quarts of A used to make Diablo. AR is quarts of A used to make Red Barons, and so on. Okay? And using these 6 decision variables, we have a complete LP formulation like this. And our objective is to maximize profit, right? And then what is your profit if you produce spicy Diablo? Profit from producing Diablo is selling price, right? Minus cost of ingredient A, right? Minus cost of ingredient B, right? So it's going to be 3.35 times D minus 1.6 AD minus 2.05 BD, right? Then what is your profit from producing Red Baron? Likewise, the selling price is 2.85 times R, and cost of A is 1.6 AR. Cost of B is 2.05 times BR, right? And if you combine all of this, we have the objective function like this, right? And because spicy Diablo is made by blending two ingredients, A and B, we have first constraint, AD plus BD equals D, right? Likewise, because red baron is made by blending two ingredients, A and B, we have another constraint, AR plus BR equals R, okay? And since only 40 quarts of A can be purchased, AD plus AR is less than equals 40. Likewise, only 30 quarts of B can be purchased. So we have BD plus BR is less than equals 30, right? And next, three constraints. So about the blending rules, okay? Diablo sauce is made by blending two ingredients, A and B, right? However, Diablo must contain at least 25% of A. That's why we have 0.25 times D is less than equals AD. AD is the quarts of A used to make Diablo, and D is the quarts of Diablo to be produced, right? And the Diablo must contain at least 50% of B. That's why we have 0.5 times D is less than equals BD. And finally, the red baron is also made by blending two ingredients, A and B. However, the red baron must contain at most 75% of A. So we have AR is less than equals 0.75 times R, okay? And also, by adding non-negativity restrictions for each variables, we have completed the LP formulation like this, okay? And I've got this LP formulation from Lindo. For Lindo, every decision variable has to be in the left-hand side. So, like you see here, all the decision variables so in the left-hand side. And only the constants values so in the right-hand side of each constraint, right? And if you use Lindo to solve this problem, you may obtain optimal solution with optimal objective function value of 99. And some additional informations, which includes slack or surplus values and dual price, and objective coefficient ranges, right-hand side ranges, and the final optimal table. Okay? And we are going to use all of this Lindo output to answer the following questions. Okay, question number 1. If the selling price of Diablo sauce were to increase from $3.35 per quart to $4.50 per quart, then what will be the effect on the number of quarts of Diablo to be produced? Is it increase or decrease, or remain the same? The profit of Diablo sauce has been changed to $4.5 per quart, right? Which is an increase of $1.15, right? In the objective coefficient of decision variable D. So we need to look at the objective coefficient ranges in the optimal solution, right? And according to the Lindo output, the allowable increase of D variable is 0.75, right? So $1.15 exceeds this allowable increase ranges, which means the current basis, optimal basis, will change, right? Because it will give you more unit profit than before. So the answer is the number of quarts of Diablo to be produced would increase, right? Of course, in the absence of degeneracy. Okay, next, question number 2. Which of the following is correct for this LP problem? The Lindo provides the final optimal table, right? Like this. Sorry, because of size of font, I've divided this one table into 3. So, because we know this is an optimal table, we need to decide if this LP has an infinite number of optimal solutions or exactly one optimal solution, right? And if the relative profit or the reduced cost of any non-basic variable is 0, then the current LP has an alternate optimal solution, which means the current LP has an infinite number of optimal solutions, right? And we have 4 non-basic variables. What are they? Slack 4, slack 5, and slack 7, and slack 8, right? And if you look at this, all of these non-basic variables have a non-zero relative profit. Is that correct? So this LP has exactly one optimal solution. What about number 3? If an additional 5 quarts of ingredient B were available, what will be the profit for that? Originally, the company can purchase up to 30 quarts, right? So we need to look at row number 5, right? And row number 5 is resource constraint for ingredient B. Is that right? So what does the effect on the profit if an additional 5 quarts of ingredient B were available? What information do we need to look at? Dual price, right? What is the dual price? It's the amount by which the optimal objective value would be improved given a unit of increase in the right-hand side of the constraint. However, this dual price remains valid within the allowable right-hand side ranges, right? So we need to look for the right-hand side ranges first. The allowable increase for row number 5 is 10, right? So the current dual price for row number 5 is valid because an additional 5 quarts of ingredient B is less than the allowable increase, which is 10 quarts, right? Which means and the dual price for row number 5 is 2.3. So the objective function, the profit will increase $2.30 per additional quart of ingredient B. Is that right? So because the additional 5 quarts are available, the profit will be increased by 5 times this, $2.3, which is 11.5, right? So the profit would be $99, that is the current objective function value, plus 11.5, that is becomes $110.50, right? Okay. Okay, what about number 4? Which of the following is equivalent to increasing slack variable 4? So we need to consider row number 4, which is a resource constraint for ingredient A, right? So by introducing slack variable, we may obtain equality constraint, which is AD plus AR plus slack 4 equals 40, right? And up to 40 quarts of A Hold on a second, please. What was the question? Okay. If the variable slack 4 were increased, what is the equivalent to this? Okay. Okay, then what is slack 4? Slack 4 is the unused amount of ingredient A, right? If slack 4 were increased by theta, for example, this equation becomes AD plus AR plus slack 4 plus theta equals 40. Is that right? And if you move theta to the right-hand side, we have slack 4 equals 40 minus theta. Is that right? So we may say that if the variable slack 4, which is the unused amount of ingredient A, were increased, this would be equivalent to decreasing ingredient A availability. Okay? So the answer is B, decreasing A availability. Is that right? B as in boy, decreasing A availability. Because the row number 4 is the constraint for the ingredient A, right? Okay, next, number 5. If the variable slack 4 were decreased by 10, that is from 0 to negative 10, what will be the quantity of Diablo produced? So what window information you need to use to answer this question? Substitution rates, right? And I said the substitution rate alpha ij represents how much xi, that is the basic variable, decreases as non-basic variable xj increases, right? And the substitution rate of slack 4 for variable d is negative 1. What does it mean? If slack 4 is decreased by 1 unit, the variable d is increased by negative 1, right? So if the variable slack 4 were decreased by 10 units, the variable d, that is the quantity of Diablo produced, would be increased by 10 times this value, negative 1, which is negative 10. Which means the variable d would be decreased by 10. Is that right? And in the original optimal solution, the value of d is 50. Therefore, if the slack variable 4 were decreased by 10 units, the variable D becomes 50 minus 10 becomes 40, right? Okay, what about number 6? If a pivot were to be performed to enter the variable slack 4 into the basis, then according to the minimum ratio test, what will be the value of slack 4 in the resulting basic solution? To answer this question, we may use the optimal table provided by Lindo. So slack 4 becomes the entering variable. Then we need to perform the minimum ratio test. These are the substitution rate, and these are the right-hand side values, right? However, the row number 2, 5, 6, 7 will not be considered because they do have negative substitution rates, right? And the minimum ratio test would be 2 over 20.5 over 5, 1.5 over 15. And this is 0.1, 0.1, 0.1, right? Is that really? Okay, I was confused. 20 over 2? Oh, yeah, maybe, yeah. Yes, I think you're right. So it's going to be 20 over 2, 5 over 0.5, 15 over 1.5, right? It's going to be 10, 10, 10. So we have ties, right? What does it mean? The resulting solution will be degenerate. Okay? With all three of the variables, I believe is R variable, AR, and BR variables decreasing to 0, right? So the value of slack 4 in the resulting basic solution would be 10, right? That is the ratio of right-hand side over substitution rate. Any questions so far? Okay, what about number 7? If the variable slack 4 were to enter the basis, then which variable will leave the basis? Well, I think we've already done this in previous question. According to the minimum ratio test, there are 3 possible pivot rows. Those are the row number 3, 4, and 8, right? This is row number 3, 4, and 8. So either R or BR, is AR or BR could be selected to leave the basis, right? So the answer is, if the variable select 4 were to enter the basis, then the variable leaving the basis is either R, BR, or AR, right? Next, number 8. If the variable select 4 were to enter the basis, which of the following is true? I think you must be able to answer this question because we have already done this in question number 6. We have ties in minimum ratio test. That means the resulting solution will be degenerate, right? With all 3 of the variables, R and AR and BR, decreasing to 0. So the answer is B, right? The next table is degenerate. Okay, next, we are required to construct the dual problem. Because the primal problem has 7 constraints, the dual problem must have 7 decision variables, and the primal problem has 6 variables, which means dual problem must have 6 constraints, right? So if I use y variable as a dual variable, decision variable, the right-hand side values in the primal problem becomes the objective coefficient, the dual problem, right? So it's going to be 0, y1, 0, y2, 40, y3, 30, y3, y4, 0, y5, y6, y7, right? Subject to wow, we have a lot of decision variables. And primal objective coefficient serves as a right-hand side value in the dual problem. So the first right-hand side value becomes 3.35. Second would be 2.85. Third is negative 1.6, and so on, right? Since we have 6 constraints, Let me just copy the dual variables for each constraint. 7. The transpose of primer constraint coefficient becomes the constraint coefficient in the dual problem. It's going to be -1, 0, 0, 0, -0.25, -0.5, and 0. Okay? And the coefficient for the second constraint would be 0, -1, 0, 0, 0, 0, -0.75. Third constraint would be 1, 0, 1, 0, 1, 0, 0. And the fourth constraint would be 0, 1, 1, 0, 0, 0, 1. Okay? The fifth would be 1, 0, 0, 1, 0, 1, 0. The last constraint would be 0, 1, 0, 1, 0, 0, 0. Okay? And we can use this table to obtain the right direction for each constraint, the sign of each variable, right? Because every primal variables are non-negative, the maximization problem, every variables has greater than equal sign, which means in minimization problem, every constraint should be greater than equal sign, right? So it's greater than equal. Okay? And the first and second constraint, the maximization problem, is equality, right? First and second constraint is equality constraint in the maximization, which means in the minimization problem, the corresponding variables, which means the first and second variable should be unrestricted in sign. So y1 and y2s are unrestricted in sign. Okay? And the maximization problem, third, fourth, and last constraint are less than equal sign, right? In maximization problem, third, fourth, and the last constraints are less than equal sign, which means third and fourth, the last variable in minimization problem, should be greater than equal 0, right? y3, y4, and y7 should be greater than equal 0. You're almost done. In the maximization problem, fifth and sixth constraints are greater than equal sign. the maximization problem, fifth and sixth constraints are greater than equal sign, which means the minimization problem, the fifth and sixth variable should be less than equal sign, less than equal to 0, right? y6, so less than equal to 0, okay? So we have completed the dual problem. Okay, what about number 10? What is the optimal value of dual LP? Last time, we've answered this type of question using the duality theorem, right? So duality theorem tells us the simplex multiplier vector pi provides an optimal solution to the other problem, right? And Lindo provides dual price instead of dual variable, right? And in the maximization problem, dual variable is same as dual price. But in the minimization problem, dual variable is negative sign of dual price, okay? Because the improve means increase in the maximization problem. However, improve means decrease in the minimization problem, right? And currently, the dual prices are negative 2.35, negative 4.35, 0.75, 2.3, 0, negative 2, and 2. Which means in the other problem, in dual problem, y1 value should be the first dual price, y2 should be equal to this, y3, y4, y5, y6, and y7. Okay? Using these y values, the dual objective function value would be 99. Okay? Or if you use the fundamental duality theorem, it is much simpler. One of the fundamental duality theorem tells us if one problem has a unique optimal solution, then the other problem must have a unique optimal solution with the same objective function value. Okay? That is, the optimal dual objective should be equal to the optimal primal objective of 99. Okay? Isn't that so easy? Okay, I think we've done the first example. Now, let's move on to the second example problem. Which is a plastic cladding problem. Okay, it's not ready, then let me use the overhead slide. Okay, next example is about plastic cladding company problem. A manufacturer produces two types of plastic cladding. They have the trade names. They are N-Color and Bestlight. So 1 yard of N-Color requires, for example, 8 pounds of polyamine and 2.5 pounds of diurethane and 2 pounds of monomer. Okay? And 1 yard of Bestlight needs 10 pounds of polyamine and 1 pound of diurethane and 4 pounds of monomer. Okay? And the company has in stock 80,000 pounds of polyamine and 20,000 pounds of diurethane and 30,000 pounds of monomer. Okay? And the contribution to profit on N-Color is $10 per yard. And on Bestlight is $20 per yard. Okay? Where is that? Okay. Okay, here. And like it says, those plastics can be produced by alternate parameter settings of the production plant, which is able to produce sheeting at the rate of 12 yards per hour. The total of 750 production plant hours are available for the next planning periods. Okay? The company has a contract to deliver at least 3,000 yards of N-Color, and you are required to determine the best production plan which maximizes the company's total profit. Okay? Those are the problem description. And we have a complete LP formulation like this. We define the variable A and B. A stands for the number of yards of N-Color produced. B is the number of yards of Bestlight produced. Okay? And our objective is to maximize profit, which is 10 times A plus 20 times B, subject to set of constraints. The first three inequalities are the resource constraints for each ingredient: polyamine and diurethane and monomer. Okay? And according to the problem description, we are able to produce sheeting at the rate of 12 yards per hour, right? And the total of 700 hours are available, right? Which means the alternate method can produce both plastics up to 12 times 750, which is 9,000 pounds. Okay? That's why we have A plus B is less than equals 9,000 as a constraint here. Okay? And the last constraint represents the contract requirement. The company needs to deliver at least 3,000 yards of angular. And adding the non-negativity restrictions for each variable A and B, we have completed the LP formulation for this problem. Any questions about the problem formulation? And I've got this LP formulation from Lindo. And we've got the optimal solution like this. And constraint coefficient ranges. And right-hand side ranges. And the final optimal table from Lindo. Okay? So, we are ready to answer questions. Okay, question number 1. How many yards of bakelite should be manufactured? What is the answer? 5,600. Yeah. Probably looks like it's too easy to answer the question, right? B is the number of yards of bakelite produced. According to the Lindo output, the optimal plan tells us we should produce 3,000 yards of angular and 5,600 yards of bakelite, right? So the answer is 5,600 yards. Okay, question number 2. How much of the available diurethane will be used? Row number 3 represents resource constraints for diurethane, right? I'm sorry?
We have a slug, we have unused.
Yeah. So let's introduce slack variable to make equality constraint. Becomes B plus slack 3 equals 2,000, right? And here slack 3 is the unused amount of diurethane. Is that right? And according to the Lindo output, slack variable for row number 3 is 6,900. Okay? And the company has in stock 20,000, right? Okay. And the unused amount of diurethane is 6,900, which means the company should use 20,000 minus 6,900, which is 13,100 pounds of diurethane. Okay? So this is the answer. Okay, how about number 3? How much of the available polyamine will be unused? And the rule number 2 is the resource constraint for polyamine, right? Again, we can introduce slack variable for row number 2 to make equality constraint. And slack 2 is the unused amount of polyamine, right? And the current optimal solution tells us slack 2 is 0, which means the unused amount of polyamine is 0. Okay? It's very easy, right? Okay, what about number 4? Suppose the company can purchase 2,000 pounds of additional polyamine for $2.50 per pound. Should they make the purchase or not? So how do you answer this question? It's a little bit complicated. Yeah. Zero price? Yeah. Yeah, that's great. Okay. So let's see. Okay, so the company has in stock 80,000 pounds of polyamine, right? And the rule number 2 is the resource constraint for polyamine. And let me just rewrite down. If we introduce slack variable for this constraint, then we may obtain equality constraint like this, right? And I said slack 2 is the unused amount of polyamine, right? So, purchasing an additional 2,000 pounds of polyamine would force the variable slack 2 to become negative 2,000. Is that correct? In other words, purchasing an additional 2,000 of polyamine would force the right-hand side value to become this one. $82,000. Okay? Is that right? So we need to look at the dual price. Because dual price is the amount, is the improvement in the objective function value resulting from a unit increase of the right-hand side value of the constraint. However, this dual price remains valid within the allowable right-hand side ranges, right? In our example, the allowable increase limit for row number 2 is 4,000. Okay? So increasing 2,000 pounds of polyamine is still within the allowable increase limit of 4,000 pounds, right? So the current dual price for row number 2 is valid. And we have a dual price of 2 for this row number 2, which means the objective function, the profit, will be increased by $2 per additional polyamine purchased. Does that make sense? However, they can purchase 2,000 pounds of polyamine for $2.50 per pound. So what is your conclusion? They should not make the purchase, right? Okay, what about number 5? Regardless of your answer in previous question number 4, suppose they do purchase 2,000 pounds of additional polyamine. Which of the following is equivalent to this? I think we've already answered this question in the previous question number 4. We've learned purchasing 2,000 pounds of additional polyamine is equivalent to decreasing the slack variable. So the answer is decreasing the slack in row number 2 by 2,000. Is that right? Okay, number 6. If the company purchases 2,000 pounds of additional polyamine, what is the total amount of best light that they should deliver? From the previous questions, number 4 and 5, we've learned purchasing 2,000 pounds of additional polyamine is equivalent to decreasing slack 2 by 2,000, right? You have to keep this in mind. Okay, then what is next? We need to look at the substitution rate, right? According to the substitution rate of slack 2 for best light, it is 0.1. So how would you conclude? As slack 2 increases 1, the basic variable B decreases 0.1. Is that right? So as slack 2 decreases 2,000, the basic variable B increases 2,000 times 0.1. Is that correct? So if the company purchased 2,000 pounds of additional polyamine, the total amount of backlight delivered would be the optimal solution. B is 5600, right? So it's going to be 5600 plus 2000 times 0.1, which is 200, right? So it becomes 5800 yards. Okay? Are you following me? Right? Okay. Okay, then I'm going to stop here for today, and next time I'm going to finish up this example problem. Okay? And let me know if you have any questions. You may email me or stop by my office. Okay? Thank you. I will see you next time. Bye.